My name is Mason Peterson. My group partners are Brendan Lakinen, Krishna Shavan, and Pratik Wagmer. This is our graduate project. It is on conveyor line color object sorting using a monochrome camera and color light filters. Our system uses a PLC as the main controller with an integrated HMI for user input selection. It takes red, green, and blue parts on a conveyor that the PLC controls and moves them into the robot work cell, where they are imaged by a monochrome camera that is connected to the robot controller, and the software on the robot controller that is machine vision is Fanuc IR Vision, and it analyzes the images of the cubes that are taken in the program. Based off of the output of the machine vision system, the robot controller determines what color part is present and communicates that with the PLC. The PLC then determines if the part is going to be allowed to stay on the conveyor and move past, or if it needs to be removed by the robot. What determines if it's going to stay or be removed is the user inputs that are given either on the HMI or through the selector switches, which are selector switch 1, 2, and 3 that correlate to red, green, and blue. And then on the HMI there's buttons for red, green, and blue blocks that you can select, and then also on the HMI you can control the start and the stop of the conveyor. Once a part is either passed or removed by the robot, the cycle will start over and the process will continue, and the PLC will iterate through all the parts on the conveyor until it doesn't have any more parts to sort through, or the process can be stopped by the operator at any time by hitting the stop button on the conveyor or the red stop push button on the programming controller system. And the program can also be resumed by hitting the start button on the HMI or the green push button on the programmable controller system. Even if the robot is in motion, hitting the stop button will hold it in place while it's in motion, and then hitting the start button will resume the motion of the robot. The way that the machine vision system sorts through the colored parts is it uses 3 different light color filters and an LED ring light that shines a certain color of light specified by the program. So if you'd like to scan for a red part, you shine red light on it from the LED, and then you use the red filter placed in front of the machine vision monochrome camera, and only red parts will be seen in that image as lighter colors or like a light gray or a white, and everything else, the background and the non-red parts, will come up as black or dark gray. And then same goes for blue and green parts. So if you want to find green parts, you can shine it with green light and then place the green filter in front of the black and white camera, and the green part will show up as lighter than the other parts, and the machine vision system can sort it out that way by contrast. And then also for blue. This is the ladder logic program that is on our Allen Bradley PLC. The first rung here is just a latching enable bit. So the latch can either be triggered by the physical push button start or the HMI start, and then it can be stopped by the physical push button stop or the HMI stop. And this enable bit basically powers everything else in our ladder logic here. So on the first bit, it enables the hold on the robot, which turns the hold off, meaning that the robot can move. And then the second rung here allows us to power the robot. These 3 bits here need to be on for the robot to execute programs and be in motion. And then rung 3 here is default reset. This is a manual push button, and it resets any faults on the robot, whether that's if an E-stop was pressed at some point, or the teach pendant was switched on, or the robot goes into singularity. You can use that to reset the robot. And then this 4th rung here is to stop the robot. So we have an examine off on our enable, so if our enable's off, then this rung is true, and it triggers the robot stop to make sure that the robot stops and no one gets hurt if the system is stopped. Rung 5 here is to control the conveyor motor. The conveyor motor is basically on if the part is not in the way of the beam sensor, and if the scan program of the robot has not already been run and the enable bit is true, then the conveyor motor is on. And then the conveyor can also be toggled on by this branch here. This is a robot program output. In the robot program, if the PLC tells the robot that the part is good to pass, then the robot will toggle this bit on for about a second, and it moves the part past the beam sensor on the conveyor in order to make this first rung true again, and then the conveyor will just continue to move forward on its own until it is made false, or the conveyor motor stops by a part interrupting this part detection, or the beam sensor. The sixth rung here is for the robot scan program. So this robot output data 0.8 is calling a program on the robot, and then to start this program, the start bit needs to be toggled on and off, which we'll look at in a second. So the way that this program is called is if a part has been detected and a scan has not already been done and the enable bit is on, then the scan program will run. So basically, as soon as a part hits the beam sensor, the conveyor is going to stop, and it's going to call this program from the robot. And like I said, that needs to be told to start. So this bit here actually just tells the robot what program it's going to use, but it doesn't tell it to start running it yet. So to do that, we have to jump down here to rungs 10 and 11 really quick, and we'll go back up to where we were after this. But basically everything else in between there at this point in running the program is going to be false. And when you get to here, this is how we tell our program to start. So I have a timer on delay, and it is either triggered by the scan program being called or the remove program being called, which we'll see in a little bit. So if the scan program is called and the enable bit's on, it starts this timer. And for as long as this timer is enabled and before the timer is done, it's going to energize the start bit on the robot. And this is just a light here that I have for reference when we're running it to make sure that this is happening, because the start bit only toggles on for half of a second, so I want to be able to see if that's happening. And when that's done, then the robot will actually start moving and run through its whole program. And then once that program is done, it switches this scan done bit to on, and it's going to make all these examine off statements false. So the conveyor won't move forward and the scan program won't continuously run. And then there's another delay here that we needed to add when the scan is done. It starts up just to give the robot a little bit of a buffer before starting the next program. Rung 8 here is the actual logic of the part color, and it determines if the robot is going to remove the part or if it's going to be passed along on the conveyor. So for example, if we had a red part here, we could select the red block switch selector, which would allow the system to pass red parts, or you can press the red block button on the HMI. And if either of those are true and a red part is detected, which is what this is here, this is the robot output or the PLC input of a red part being present, and then same thing for green and blue down here. But say that's true, where we have a red block selected as what we want, and then a red block does show up as present from the robot, then the part match bit will be on, and the robot will see that the part does match, and it can move along in the conveyor. Rung 9 is what's actually going to run that program that's going to remove or pass the part. It's called a remove program here, but it's both the remove and the pass program. The logic is done on the robot program for the sorting part, which it uses that robot part match bit to determine what's going to happen. So basically this one is true if the scan is done, if the enable bit's on, and if that buffer timer has completed, which was 200 milliseconds. So after 200 milliseconds is passed, after the scan is done, then it's going to turn on this output. And then again, we have to toggle the start bit to actually start the program. So that is going to happen here on rung 10. So the robot, or the remove program is going to be on, enables on, starts the timer, and then toggles the start button on and off, and the robot program will execute. This is the first robot program, the scan part program. Within here we have 5 digital outputs that we're mainly using for color. The first 3 here that we're turning off at the start of our program, digital output 123 through 125, are what the robot uses to tell the PLC what the color part is that it found. And then these other outputs here, digital output 110 and 112, are to call a color, and these are actually what go to the Arduino unit to switch the filter in front of the camera and to switch the light color that is seen by the camera. So the first part of this program is to wait a half a second. This is just in case the filter selector was not already in the red position. It gives it a little bit of time to move back to the red position. And then line 8 here, the Vision Run Find Red Scan, is telling the vision system to scan for a red part. The next line, line 9, is to get the offset of the part that it just scanned. So if a part is found, then it's going to save the positional data to the vision register here, and then it will move on to the next line. But if a part is not found, meaning that there is no red part present, it's going to jump to label 10, which is right here on rung 11. But say a part is true, before it gets to label 10 here, it's going to turn on the red output, meaning that a red part is present. So the path again here, if a red part is found, it just jumps down to line 10. If a red part is not found, it jumps over line 10 to line 11, and it doesn't turn on that output. And basically the same thing happens for the green and the blue color cases. So it'll turn on a output that'll call green, so this is what goes to our Arduino, and the Arduino then switches the filter in front of the camera and switches the light color of the LEDs. It waits a half a second to allow this to happen, and then it's going to scan for a green part. If the green part is found, then it will turn on the output and save the positional data. If it's not found, it's going to jump over, turning on the output, and then we turn off the call green output after that to tell the Arduino that we no longer need the green filter and the green light there. And then for the blue, we just turn on the blue call, which the Arduino again switches, and then scans for blue, turns on the output if blue is present, and then turns off the blue output. And then this last line here, this digital output 130 scan complete, this is the scan complete bit that is seen on the PLC program. This is just turned on at the end of the scan program, and it's actually turned off at the end of the other robot program. This prevents the conveyor from moving forward when the robot actually picks up the part and moves it out of the way of the beam sensor. If this was not here, then as soon as the part is picked up by the robot and moves out of the way of that sensor, then the conveyor would start up and would be in motion while the robot is also in motion, which we want to avoid. This is the second robot program. It's the sort part program. It starts out by defining the user frame number and the tool frame number, and then telling the robot to move to position 1, which is the home position, and it is right above the part reject bin. Line 5 is the line that actually controls the part sorting logic. Digital input 121 here is the digital output of the part match bit on the PLC program. So if a part match is found, then this input is turned on, and if this input is on, then this program is going to jump to label 10, which is down here on line 20. From here, it's going to toggle on digital output 126, which correlates to the conveyor forward bit in the PLC program. That stays on for 0.75 seconds, and then it turns back off. Again, this just moves the conveyor a little bit forward so that the part is out of the way of the beam sensor, and then the conveyor forward rung is made true again just because the beam sensor is not blocked anymore, and the PLC will execute the rest of its program there. And then at the end of the program, we turn off all of those color bits so that the next cycle can use them without any overwriting. And the last line is to turn off the scan complete bit that's also used in the PLC program. So in the case of this digital input 121 not being on, meaning that the part is not matching the requested color that the user inputted, this program is going to execute everything below line 5 up until line 19 here, where it jumps over the conveyor toggle on off logic and then goes to the end of our program where it turns off all the colors and the scan complete. So what this is line 7 here moves to the spot right above the part. This VR1 here is the positional data that it gets from the machine vision system, or the IR vision. And this other PR81 here is the Z offset, so this is just offsetting our tool a little bit in the Z so that we're not going straight to the top of our part from some angle. So we approach the part from the top, and then we come straight down on line 8 right here, and then we wait for a second, and then the next line is to turn on the suction cup, and then you wait for another half second. And after this, the part should be grasped by the suction cup, and then on line 12, the robot moves back up above the part, and then moves over above the part dump bin, and then down into the part dump bin, and then it turns off the suction. And then from there it jumps to label 11, which goes to the end of the program.